Now for the auto resizing, this is going to be used as an actuator. Here I have a pancake motor, I have a flux, I have a coil, I have another flux, I have a coil, and I have another flux. This is an iron steel flux. Here I have a linear motor actuator. I have a flux and I have a coil. I have a flux and I have a coil. I have a flux and I have a coil. I have a flux and I have a coil. I have a flux and I have a coil. Now in between the flux, this is an aluminum flat bar. So it is driven through like a bore, like a solenoid bore, a flat solenoid bore. However, this top must be coated separately, and this linear motor must be coated separately in epoxy resin crystalline hardener. Thus, that they may be reconnected and then coated along the sides to bind together and exhibit the linear motor should move on a smooth surface as far as the bore. The bore is a flat bar. This flat bar, which then connects to a chain linkage of flat bars for biaxial rods bearing either latches or bearing either servos to control each additional part of this metric range. Each part is to operate as either a linear motor and an actuator. In the vertical position of the body armor of Mark 42, this is upward. However, I'm going to make blocks here so that the parts only have a short distance of guide onto the rail. This will operate as a rail. However, it will be a blocking point to allow it to stop. So when auto resizing, and connecting and transforming back to the body, I have a block here and a block here so that it does not exceed the direct. However, having a electromagnet pad where I'm cutting out 4 frames and frame 4 electromagnet to connect to other parts. Unisys. Here I have on the floor that I'm going to pick up, which is another large mass. That's just a small part of the This is a large one. And there you see the board, but this board does not move in and out. This just connects to another mountain part. See the linear motor where I use the flux in between each one. This is a smooth surface because I already have resined it. Now I'm going to add the flux around here wire to couple alongside here to increase the electromagnetic field. This is about over 500 turns of coil. And this one I have 3. 1, 2, and 3. This is another more than 500 turns of coil, winding coil. And it's fixed over the linear actuator. And that will enable it to move forward, backwards, and also vertically in the air. Hover mode, whereas because of the bore, and the aluminum bore is going to try to escape, moving it forward and backwards. Nevertheless, at the same time, because of the electromagnetic winding of these 3 coils, will cause in the flux, will cause it to lift in the air, it hover. So, therefore, the following parts after I place that on here, I'm going to be adding ball bearings. These ball bearings, brackets, are going to be turning an armature. I'm going to have a fan inside there, and then I'm going to lift up another cage of coil so that I can snug the fan within the coil. And the fan, like I said, is going to be a transductor fan, which is going to have coils on it. And there's no need to have a DC phase charge. It will be synchronous by the coils back behind here and move the aluminum fan. But the fan shall be also operate as a gyroscope. The gyroscope will have the fan blades will be in the central, exhibiting a ring at its ends, where the ring is of weight and will allow it to have more kinetic energy. Nevertheless, the ball bearings, this is one part of the bicep, and this is the other part of the unit. Now, nevertheless, the housing, like I said, to make a case so I can hold the blade in, and the stack, it's going to be with stacked aluminum and copper sheets to create at least 1 millimeter thick to create the blades, the inductor blades, and then I'm going to cut into a C-frame each blade to one coil around it, and to allow the ends to be sharp, and the ends to be sharp at the central of the blade will have a transductor wire, and that's for that part. So the other part, like I made like this, where I apply the bore into it, whereas I'm using this aluminum, so I can apply the ball bearing bracket for the rotary to cool the system. Now I'm going to make another one of these for the following, because I have to make it to each part, making the entire suit, and I have to use these boards to connect these things in a chain, so I have to lift the housing will on its own and stand on its own, so I plan to use servos in order to connect to each part in the horns. However, to increase the horns using a hard steel, especially made steel horn for the servos, robot servos, to move to actuate these different parts, to open and close the machine of Mark 42, and to connect by solenoid electromagnetic hole. My name is Ray Morton, goodbye.